When we want to conduct a hypothesis test with two independent samples and we want to compare those samples together, the process we will go through is pretty similar to the process we did to compare two different proportions to each other. We just need to make sure we know the formulas that are specific to the context of two independent samples. So let's look at some formulas we need. And the first one is the ugly one. This one you do not need to memorize. You would look this up or have a formula sheet in application. And that's the formula for the degrees of freedom. The degrees of freedom for two independent samples, if we can't assume the variances are the same, is a little bit of an ugly formula. Here's what it is. In the numerator, you're going to have the standard deviation of the first sample squared divided by the sample size of the first sample, plus the standard deviation of the second sample squared divided by the sample size of the second sample. And that whole thing is squared. And then we divide by, in the denominator, 1 over 1 less than the first sample size times the standard deviation of the first sample squared divided by the sample size. And all of that is squared, plus 1 over the second sample size minus 1 times the second standard deviation divided by the second sample size squared. That formula is what we need in order to calculate the degrees of freedom. We'll call that formula A. Once you have the degrees of freedom, we also are going to have to calculate the standard error for the problem. With two samples, the formula for standard error is the square root of the first standard deviation squared divided by the first sample size plus the second standard deviation squared divided by the second sample size. And then once I have that information, then we're ready to actually calculate the test statistic t. The test statistic t that we're going to use to compare two different means is we're going to take the first average, subtract the second average, and divide it by the standard error. Now, I do have one tip that might help for doing these calculations to make the formulas easier to type in your calculator and use. Tip is to find the first standard deviation squared and the second standard deviation squared, or the variances, and then replace all of those with those values. Instead of having to square them in the formula, we're going to square them in advance and know what they are. So let's take a look at an example where we use these three formulas. And then in the next video, we're going to look at finding the whole hypothesis test. So for example, let's say we wanted to compare two groups to see if they had the same mean. Group 1 had a mean of 5.83. Group 2 had a mean of 6.31. Group 1 had a standard deviation of 1.4. Group 2 had a standard deviation of 2.3. The sample size of group 1 was 21. And the sample size of group 2 was 28. Let's find each of those three values. First, we're going to find the degrees of freedom. Remember that hint I gave you? It's helpful to not just know the standard deviations, but actually the variances. So we're going to first take standard deviation 1 and square it. So 1.4 squared is going to actually be equal to 1.96. And standard deviation 2 squared is going to be 2.3 squared, and that value is 5.29. So now when I look for that formula for degrees of freedom, the numerator is the standard deviation 1 squared, which is 1.96, divided by the first sample size, which is 21, plus the second standard deviation squared, which is 5.29, divided by the second sample size, which is 28. And that whole numerator gets squared. And then we're going to divide by, in the denominator, 1 over 1 less than the first sample size, which is 20, times the first standard deviation squared, which is 1.96, divided by the sample size of 21, and that fraction is squared, plus 1 over 1 smaller than the second sample size, which is 27, times the second standard deviation squared, which is 5.29, divided by the sample size of 28 squared. Be very careful with parentheses as you type this in your calculator. When you do, you should end up with 45.33 degrees of freedom for this example. For the standard error, we said it was going to be equal to the square root of the first standard deviation squared, which we just found out was 1.96, divided by the first sample size of 21, plus the second standard deviation squared, which we just found out is 5.29, divided by the second sample size, which is 28. Making sure that's all under the square root on your calculator, we end up with a standard error for this problem of 0.531. The other value that we want to calculate is the test statistic t. T, we said, was equal to the first mean, which is 5.83, minus the second mean, which is 6.31, divided by the standard error, which is 0.531. Being careful of parentheses around the numerator on your calculator, you should get negative 0.9040 for the test statistic. So yes, the formulas look big and scary for doing two means, but each one is manageable if you just work through it step by step and be careful how you put it into the calculator. In our next video, we'll actually conduct a hypothesis test where we go through these calculations, but also make conclusions about whether or not we can reject or fail to reject that null hypothesis.